So my name is Aleksei, and I'm an engineer at Fluence. And today I will tell how IPC and IPLD help us to make Fluence more decentralized. Firstly, I will speak about Fluence and then about particular solution. So Fluence is a kind of three things. First is a computer marketplace where providers globally distributed, registered on chain to provide capacity to earn from it. Second one is a cloudless stack for developers to run their application and function. And the third thing is a DAO that manages the protocol and decides what to do next for it. And today I will speak mostly about compute marketplace. For accounting, we use compute unit. It's one physical core, it's 4 GB of RAM, and 10 GB of virtual disk. And each physical server has a peer, Fluence peer, that has multiple compute units and run all the things, manage resources, etc. And one compute provider is basically multiple physical servers, multiple peers. It's all managed on chain. And yeah. So for proving that the provider has enough capacity, we have a proof of capacity. It's basically random X, which utilizes all the memory, all the CPU, and it proves that provider has this CPU, and provider stake FLT token on this, and he required to send proofs periodically and check on chain to prove it and actually been able to run developer's code. So compute unit can be in two states. One is committed capacity. It's basically at the start, it generating proofs with random X and submitting on chain. And then someone wants to deploy it, and this particular provider matched for this application. It switched from a capacity state to running cloudless function state and earning stable coins. So then I go to the why we chose IPC for it. For validating proofs on chain, we need to have a kind of huge calculation and computation, and only in IPC we can do it with custom native WebAssembly actors and really check that proof generated correctly and make it possible. So also IPC provides permission contract deployment. So on our subnet, we can run only our contracts, and it's scalable and performant. So our subnet looks like this. It has a compute marketplace. It's a bunch of contracts to manage all the registry of providers, to manage deployments. It has FLT as a native token. It has an actor for proof of capacity to check all the proofs that's submitted by providers. It has a stablecoin wrapper for USDC, and it can be plugged with fiat gateways and our actors for proving. So our IPC chain anchored to Filecoin, basically, and our FLT token is on Ethereum with DAO, and with Axelar bridges, it can be bridged from Ethereum to IPC and used there to stakes, to pay for fees for transaction, and actually deploy some code. So Fluence provider looks kind of like this. It hosts IPC validator to have good access to subnet and be independent from our validators. Also, they run a bunch of Fluence peers to actually sell their resources, manage all the capacity, and run as a sidecar capacity prover. It's this random X binary that runs proofs when these peers and services are stale and waiting for developers to deploy something. And about cloudless deployment. So actually, before someone can call it and use it, you should deploy it. And basically, to deploy something on Fluence, you just go to the website, download CLI, creating the project, put a bunch of code there with Rust and WebAssembly, or just reuse examples, and bridge tokens from Ethereum or buy it with fiat gateways. And then you send a transaction to Compute Marketplace that you want to have this number of workers, you want to host this code, and you want to run this code, and that's it. But it's not actually like it, because this is worker definition. It's what you actually want to deploy. It's has a definition of services what you created. Each service has a modules, WASM modules, and it's config, and also where it's a spell scripts, it's kind of cron jobs on Fluence. And then you deploy, when you want to deploy something, you need to upload it somewhere. And this is somewhere for us, it's IPFS node. It's like we hosted it by ourselves, and developers, it's kind of hidden in CLI that firstly you upload all the stuff to IPFS node, then you send transaction where it contains CID of this worker definition, and providers receive events about what they need to deploy. This worker definition is just a JSON. It's kind of custom format, and it's not quite good. Also, it's not so decentralized to host IPFS node and upload all the stuff for deployments there. And so we have a pros for this approach. It's kind of working, and it's suitable for testnet, I think, but for production it's not so well, because worker definition has a custom format. It just JSON. It's centralized because it's kind of one node, and it's single point of failure. It's not accountable at all, and we can do much stuff in contracts on chain to verify what's actually deployed, what's providers run, etc. And it can be fixed. It can be fixed with IPLD and IPC and IPC native factors. So basically, our worker definition is almost IPLD and DuckJSON format. So it's easy to change the format and to make it compatible with IPLD. And also, the most important second thing is that we can store all the worker definition, all the WASMs, all the configs in on-state storage in IPC. So we can make it accountable, we can make it sustainable. So one solution is to create code repo actor with WASM and run it alongside with our actor from proof of compute in IPC chain, and to make people accountable for code they want to use and deploy. So basically, they don't upload their code to a centralized IPFS node. They pay with native FLT token or with USDC on IPC. They send transaction with their code, and it's stored on state. And also, it can be used for checking in contracts, because in contracts we can access all the data fields because IPC and this actor model allows us to do it. And our deployment will look like this. So firstly, we will upload all the things to IPC via transaction and code wrapper actor, then we send our deployment transaction with CID, and we can run checks on it. We can validate that it's really okay. We can have whitelist for providers. We can have any other checks that providers run exactly with scripts. For example, about this proof of computers, like our future. It's our proof of concept. When provider runs scripts, they can send proof on chain that they really executed it, and we can compare script that they run and that's signed with their keychain, and compare it with script on code wrapper actor, so it can be compared inside the contracts. And with this, we achieved that we have a shared universal format. We have a decentralized and distributed data availability level. We make people accountable for putting stuff in our network, and it will solve those problems on overload protection. Also, we can create some proofs and validate stuff on chain in contracts, in IVM contracts. And data is available as long as the chain exists. So it's kind of good. I think that's all for me. And also you can join us tomorrow on DPN Day. It will be here. And that's all.